direction, you're going to add them up. And if you have forces that are going in opposite directions, then you're going to subtract them. Okay, so typically if they're going in the same direction, you add them. If they're going in opposite directions, you subtract. I think that's the easiest way to look at it. If you have a very good like math brain and positives and negatives make sense for you, I'm going to show you another way that you can think about it. But I think it's easier just to think if they're going in the same direction, you add them. If they're going opposite, subtract. But we're going to be looking at these vectors because we know that these visually show the forces and what they're doing. So this is slide 28. And so a vector is going to be a quantity which has both magnitude, which is size, and a direction. You guys are very good at understanding that part now. And so the length of the arrow shows the magnitude, which is, again, it's the size or strength. And then the angle of the arrow shows the vector's direction. So that's going to show the direction of the force. Is it up, down, right, left? What is it? And so just like numbers, we can combine two or more vector angles together to get something called a net force. Again, net is the sum of all the forces or a combination of them all. And then if we're talking vectors, sometimes we'll call this the resultant. So what did you result in, right? And so that's kind of where that comes from. You see the word result, which is like the ending or, you know, the answer or the amount, the ending amount of something. So we have the resultant that is combined. So if we take a vector of 8 newtons and combine it with a vector of 6 newtons, we add those two up and we get a resultant of 14 newtons. Okay, here we have 8 newtons to the right and we have 6 newtons to the left. Going back to the very beginning of last unit, remember, anything that is down, south, left, or west is technically considered to be negative. So because this is going negative, you can consider this as a negative and put -6 here. Again, I think I'm going to show you this way, but I think it's easier just to be like, okay, 8 and 6 are going in opposite directions. I'm going to subtract them. My answer is 2, and it's going to have the sign of whatever, you know, number is larger or vector is larger. Well, 8 is positive, so that's a positive. Okay. If you want to think of it as the negative, so it's going to the left, making this a -6. So 8 plus a -6 is still 2. So either way, you get the same answer. If that whole negative business confuses you, then just don't worry about it. You see them and they're going opposites, just subtract them. So one way to think of it is adding vectors A and B to get resultant C. Okay, so A plus B will give you C. And one is pointing to the right, one is pointing to the left. Obviously the right is a positive number, the left is a negative value. So 5 plus a -10 is going to leave you with a -5. The reason it's negative is because the greater force is pointing to the left. Leftward means negative. For us, again, most of the time it's going to be fine. Like if you just tell me it's going 5 newtons to the left, I know that left means negative if we were using that in a calculation. Like we're kind of there. Please don't. Thank you. Just in case it goes wild. You say that. All right, this can also be done vertically, right? 10 positive for up, 5 negative because it's pointing down. 10 plus a -5 is basically the same thing as taking 10 minus 5, and you end up with 5 positive because 10 was our bigger value, and that's pointing up. If they're going in the same direction, you just get to add them. So a +5 plus another +5 gives you +10. So again, if you want to consider it as negative, if you have left or down, that's fine. I think it's easier just to think of subtracting them if they're opposite, adding them if they're moving in the same direction. Whatever works best for your brain, go for it. And we know that the right or up value is going to represent positive. I'm shaking my board. Walking around up there. Okay, so let's take a look at this. Here's my way, or the easier way. If vectors are in the opposite direction, you subtract them. don't worry about like making one negative and you're always adding them. Just think about subtracting them. They're basically like trying to, you know, they're getting rid of each other. If the vectors are in the same direction, add them. I think this is easier than thinking of applying negatives and positives to the sign or to the numbers. But again, do whatever works for you. So if I have two that are going in the same direction, what am I going to end up as my resultant over here? What do you think, Austin? What's 5 plus 5?
10.
Okay. Oh, sorry, I thought I was there yet. Either way, if you either add the negative or just subtract, you're still always going to get the same answer. So either way you're comfortable, just do it whatever way you're comfortable. Austin told us that when you combine those, you're going to get a net force or a resultant of 10 newtons. What about for this next one? They're going in opposite directions. So 5 to the right, but 5 to the left gives you what? What do you think, Dylan?
0.
Good. Nice mental math. And then 5 to the right, combining with 10 to the right. Good. And 5 to the right and 10 to the left. -5. Or you can think, you know, 5 minus 10. Well, you're going to end up with a -5 that way. 5 plus a -15. Where do we get there? What do you think, Will? Good. Again, the negative is assigned because we know that it is the force that's greater, and so you take the sign of the greater force, but really this is just saying it's 10 to the left. Okay. 10 up, 5 down. What are we going to end up with? What do you think, Charlie? Good, and it's going to be 5 in the upward direction. Good. So really, I mean, we talked about this last year. We did some of this practice, so shouldn't be too shocking or new. All right, so a force diagram, and that's kind of what we're going to move into after we do some practice, is going to show all the forces acting on an object. So again, we're typically going to use a box so we don't have to draw the little person, but we know that the force of gravity is pulling down. We know that normal force is going to work perpendicular. The yellow shirt kid or person is on the slide, so the slide is at an angle. So one of the main criteria of normal force is that solid to solid has to be in contact and it's going to work perpendicular. So we know that the boy, or yeah, it says boy, you know, at the top of the slide is experiencing normal force as well, but he is on the horizontal flat surface, meaning that normal force is perpendicular to that. So look how it cancels out the gravity. You're getting balanced forces, so you're getting no change in motion. Here they're not balanced, they're unequal. And so this is why it feels like gravity is stronger, and that's why it's going to actually pull the boy downward unless he like sits there and tries to hold on and not get pulled down the slide. Okay. So here we have equal and opposite forces, so you don't get any movement. Here, you do not have equal and opposite, right? And because of that, they do not cancel out, and so you are going to get a change in motion. Balanced forces, you get no change. Unbalanced, you will get that change. Okay, and then finally, we're going to look at some more examples that kind of look similar to this. This is a more traditional free body diagram, all right, where this is representing kind of generically whatever's being described, the couch, a dresser, a person, a ball, whatever it may be, okay? So the diagram shows the situation, and it's going to show all the forces acting on it. And so you notice that it has the little code of force of tension and force of gravity. So in my mind, force of tension, because this is showing vertical, it's like something is hanging. So maybe, you know, it's like a cable, or maybe like a rope swing from a tire tree, something like that, okay? And I see that gravity is pulling down with 800 newtons, but I see that that the tension force is pulling upward with 1200 newtons. All right, so what we end up with is we have our tension and our gravity. What's going to be the overall force acting on this object? Those forces are working in opposite directions, so are we gonna add them up, or are we gonna subtract them? What do you think, Cade? If they're in, yeah, they're in opposite directions, so if we just take our 1200 minus our 800, we should end up with 400 newtons. And I know that it's gonna be in the upward direction, because 1200 is bigger than my 800. So this shows, like, using the signs, 1200 plus your negative 800, or think about it, they're opposites, you can just subtract them. 1200 minus 800 will give you the same answer of 400. Include the unit of the Newton and the direction up. Okay, so we'll look at a lot more examples of those here in just a second. All right, let me. All right, this is a really good brain pop. It does a good, oh, yeah, stop it. Thank you.